Hi, this is Tim. In this video, we're going to continue building on our Yamaha Scara project. In previous videos, we have configured our robot to communicate with our CompactLogix PLC over Ethernet. We have configured all our points. And in this video, we're going to talk about how we can make it move through a sequence, such as pressing the green button, yellow button, red button, blue button, and then switching switch 1 to the right position, back to the left position, and doing it again. In this video, we are using the Yamaha Scara YK500 XGL, and we're using our CompactLogix trainer. And I'll put links to both of those in the description. And before we get started, please take a moment to like this video and subscribe to our channel. We put out at least one automation video a week. And any questions that you have, feel free to put them down in the comments. This whole series is based off a question that many of you asked about, hey, how can we integrate robots and PLCs? And honestly, I had no idea how to do this when I started. And I really could have never imagined that Yamaha would have made this as simple as they had. So let's start off by recapping what we've done so far. We added our robot into our Ethernet configuration as a generic Ethernet module, and we imported these two AOI instructions. This one right here allows us to teach positions, and this one right here allows us to move to positions. So for example, if I put in point number 16 and I toggle this bit, then it's going to move to the blue position. So we programmed all of these positions in, and now what we want to do is sequence through these positions. Now we just finished up a sequencing series where we went through various different ways that we could sequence machine steps. And this one we're going to use indirect addressing. We have all these different points that we have to sequence through, and so I've written them down just so we can see them. So our green up is 10, green down is 11, but each one of these point numbers is a different place. And then these are the position steps that we need to go through to actually do that process of testing that I just talked about. So we've got to go over the green button, then we got to press the green button down, and then we're going to have to go back up. And they're going to go to yellow button position, then press the yellow button, and then go back up, and so forth. So I could write 18 lines to do this, and that wouldn't be a big deal. But I think as we add to this, that could make it more difficult. So we want to index through these positions using a counter, and in that way we can just reuse the same rung. So let's start by bringing another rung down, and let's go to our favorites tab and bring down an examine on, and we're going to need an auto sequence. I'm going to create that, and then let's get our timer counter tab and bring down a counter. So this will be our sequence number, so we'll create that. And I'm probably not going to use the preset, so I'm just going to set the preset at 100 for now. We may have to come back and adjust that later. And then let's bring down another rung, and let's go to the Move Logical tab and bring down a move instruction. And we're going to need to create an array for this, and this is going to be our point array. And let's go ahead and take care of that. So right-click Point Array, New Array. And typically, we just make sure our data type's correct and we hit the Create button. We haven't done a lot with arrays though. So if we click the dialog box to the right of it, then we can have this dimension column down here. And so this is what we're going to use to index through here. And I am just going to throw 300 in here. That should be an ample amount, but these will be different positions that we can index through. So we're going to create that. And then just to show that we're going to have an error, let's go ahead and put our destination in. And our destination is going to be this point number up here. So point number. And you can see that we're getting an error right here. And let's go ahead and hit the verify button just so we can understand our error. Bring that up a little bit. Missing reference to array element. So whereas here we just type in point number, in this case, we actually need to specify which element, because since we made 300 of these, we have 0, all the way through 299 there. Well, what we're going to do is instead of entering a point number, we're going to use the sequence number to index through them. So I'm going to put open bracket, and then see it wants to fill in 0 close bracket. Well, now I'm going to put in sequence number dot ACC, which is this counter right here. It's going to be this accumulated value, which right now is at 0. So, and then I'm going to put a close bracket, enter, and our red X's went away, so we're good there. So let's put this in now, just so we can make sure we understand exactly what's going on with this indexed address right here. So I'm going to put this in, and then let's put some values into this array. So let's right-click point array, and we'll monitor point array, and then we're going to open it up, and here are all those points, and they're all at 0 right now. Right here are the values that we actually want. So the first thing we're going to do is move to the green button's up position, and then the down, and so forth. So these are the values we wish we could copy and paste, but we're not going to be able to. So I'm going to manually type these in. So our first one was 10, and then we want 11, and then we're going to go back to 10, and then we're going to go to 12, 13, back to 12, 14, 15, back to 14, 16, then 17, and then back to 16, and then 18, then 19, then 20, and then 19, then 18, and then 10. So that gets us points. Yep, that's 18 points. So this gets us at least to a starting point on how this is going to work. Now let's go back over here and look at this. So now that we have 10 in point array 0, and our accumulated value of sequence number is 0, it's moving a 10 into point array. Now I'm just going to manually type a value of 1 into our accumulated value of sequence number. And notice this changes to 11, which is the point number of number 1. So then, if I put a number 2 in here, it's going to go back to 10. 3 is going to go to 12, which is over our yellow button. Then 4 is going to put it at 13, which is pushing the yellow button, and so forth. So the next thing we got to do is we got to make this counter actually count. Well, I want to count when our move instruction process is complete, this bit right here. So I'm going to bring down, we'll start an wrong edit there, and then I'm going to bring down another examine on, and then I want to look at this move instruction dot PC. That's our process complete bit. Now the only kicker to this, and honestly I can't decide whether this is going to be an issue or not when I'm looking at it, is I'm a little worried. See, right now this process complete bit is already set. I think program scan will take care of this, but I also want to make sure that we have executed this before we look at this again. So what I'm going to do is I'm going to go to our compare tab, and I'm bring down an equal statement. And we're going to look that our point number, actually point number or sequence number? We want our sequence number, that our sequence number is equal to our previous sequence number. This may be an unnecessary step. I can't decide. Actually, this is sequence number .acc. And then I'm going to create this. And then right up here, I'm going to edit this one and put a move instruction in. And then I'm going to move the sequence number .acc to the previous sequence. This is going to make sure that this move instruction is executed before we end up doing this. Like I said, I think this is redundant. I'm just not sure yet. Also just realized I kind of threw this process complete in here really fast with no explanations. Let's back that out and talk about it. Let's put that back in. This is the same thing. Now we just have this interlock here. And then I'm going to go ahead and turn some servos on. And enable that. When do we want to actually count up here? And we can use this process complete bit right here for our move. So every time that the robot moves, the in process bit comes on and the process complete bit turns off. And then once it's at its position, this comes back on, the process complete. And let's show that. So if I put in an accumulated value of 8, that's going to put us at position 14, and 14 is our red up position. So hopefully we can see enough of this. I'm just going to toggle this bit, and for a split second, you're going to see this in process come on. There you go. You see how it came on and you saw the process complete bit drop out? So the process complete bit comes on every time we want to index this sequencer. So let's edit this rung and go to our bits tab and bring down and examine on, and then we're going to look at this move instruction dot process complete. So that's going to make it index up each time the robot has made a move. Now, I'm not sure how we're going to start this over yet. So for now, I'm going to also add a less than instruction. And we're going to look that this sequence number is less than 17 because that's our last move. But all right, that'll get this counting. Now we need to make the move happen. Well, you know, even before that, we can test this code just manually toggling this bit. So let's put this instruction in and let's set our accumulated value here to 0. Okay, so now when I toggle this bit, it should move to the green button position. So I'm going to toggle that bit. All right, and it does. And then if we look at our sequence number now, it is 1. And it is wanting to go to position 11, which is the down position. And so if I toggle that bit again, it should go down. Okay, and also notice we got our green light on. Now, if I toggle it again, it should go back up. And just so we can make sure we see what's going on here is each time we're doing this, we're indexing our sequence number. So our next one is 12, which should be over the yellow button position. Toggle, yep. Toggle again, yep. Toggle again, toggle again. All right, I think we've got this, hopefully. For those famous last words, I probably should have ran this through before I said I think we got this, but all right. Yeah. Whoop, I got a problem on that one. You notice that? So I went from the switch left position down and it went all the way to the right position. So I have a problem in my sequence. So let's look back at the spreadsheet I was doing and see where I went wrong here. So we have position 18, which is switched left up position. And then we went to 19, which is switched down left position. Oh, and then I should have gone to 21. That should be 21. Because that would be the switch down right position. So that's 21. And then we need to go back to the left position. Okay, and I was doing the, I was getting ready to have a mess. So and then we go back there and back there. Okay, I think the rest of it was right. Okay, so we need to fix our numbers in our sequence array so they match this. And that should get us fixed. So I'm going to go to our controller tags and look at our array. And down here is where we had the problem. I believe, yeah, we should go to 21 right here. In fact, we never go to 20. Oh, and is that the only one that's wrong? That's it. I just had that one position wrong. Okay, now we can test this again. Let's put a 0 into our accumulated value. And now when I toggle it, it should go back to the green position, and it should keep doing it as long as I'm toggling this move bit. So, toggle. All right, that gets us there. Green button, yellow position, yellow button, red position, red button, blue position, blue button. All right, yeah, we're in the left switch 1 position. It comes down. Okay, now it should switch it to the right. Okay, yeah, we're sequencing through. Now it needs to switch it back. All right, now it should go back up. Okay. And there you go. It goes back to position 1. Okay. So we've got that part. Now what we need to do is we need to make it where this part is automated instead of me sitting here toggling this bit. So I do want to keep this though, because I think we're going to need to manually toggle this. So let's better define this bit. Let's call this our manual position bit. There we go. And then let's edit this rung and add a branch over everything and drag this into the bottom one. And then first, when do we want this top branch to work? Well, that's our auto sequence. So we want to look that our auto sequence is enabled. And then I believe I can use this counter's CU bit, or better yet, not CU bit. I think that would make this index. So I'm going to bring down that. We're going to look at sequence number dot CU, and I believe that's going to work. All right, and we've got it. We don't have it where it's going to start over yet, so we're still going to manually deal with that. But let's put this in there and see what it does. Oops, I sat there and said not CU bit, and then I put examine on. Want that. So if we're in sequence, I think this will work. All right. Actually, before we do this, let's just toggle off both of these bits, just in case. And we'll put that in there. And, all right, first our accumulated value here needs to be at 0. That's the beginning of our sequence. And I believe now when I toggle this auto sequence, it should index through those. So let's find out. Toggling auto sequence. All right, that worked. So now we just need to make it, well, one, we may be done, but we could make it repeat itself here. So let's see how we could do that. We know that we're at a value of 17 now. Maybe I did wrong here. I knew that I wanted this if it was less than. I don't want to get this above 17. Actually, I think what I should have done is, yeah, right here. This should be a GEQ. Or should just be greater than 18. And it's definitely one of above. And at that point, I want to move 0 back to this. So the ACC, I want to go back to 0. I think that'll work. Okay, so let's put that in there. And we're back at our 0 position. And I should just have to toggle this and start over. So let's see what it does now. So toggle. So there you have it. We have managed to connect our Yamaha Scara robot over Ethernet to our Compact Logix controller, and we have configured all of our positions, and now we have a sequence that runs through these button presses. Now a few other things. One, we have some additional switches, and maybe we'll add those. I'm not exactly sure why we would, but we also have this potentiometer, and it's been really bugging me. these are really easy. You know, move to this position, do this thing. Well, this potentiometer, you know, if I just grab it and I move a little bit, then its position is completely changed. So I think that's going to be the next challenge, is figuring out how to operate this potentiometer and adjust it to different positions. Also, I'm sure somebody will ask, hey, could you make this run faster? And we will. In a video probably near the end, this table is not nearly sturdy enough to run this robot very fast. In fact, there's a little bit of shake to it now. But we will take this setup and put it on the floor and see just how fast we can do this. So I hope this video has helped you learn about integrating this Scara robot and moving it through sequences. It certainly has helped me learn a lot about robots. I'll put links to both the Yamaha Scara robot and our PLC trainer down in the description. Till next time. Hi, this is Tim.
And this is Amber of TW Controls. We run the automation store. Hey, thanks for finding our channel.
Here's a playlist with some similar videos.
And YouTube thinks you'll like this video.
Please like our video and subscribe to our channel.
And if our videos have helped you make some money and you're not using our products, please consider supporting us on Patreon.
Till next time.
See ya!